Hey class, this is Mr. Neugebauer again. Go ahead and open your books, turn to page 309, and we're doing chapter 4, lesson 5, compare properties of functions. Alright? Okay, number 1 here. It says Carlos's annual membership to the Science Museum can be represented by the function C equals $29.99, where C represents the cost in dollars. The cost of Stephanie to pay per visit is shown in the table right here. So for Stephanie, basically 1 visit is $5, 2 visits, she spends $10. So basically we have $5 for every single visit. So at 5 visits, she'll have $25 spent. Now, here it says make a table to represent Carlos's membership. Okay, so here we have for Carlos's membership, month 1, 2, 3, and 4. Well, notice Carlos's membership is a annual, meaning yearly membership, where he pays $29.99. Now, he doesn't have to pay $29.99 per month. That's for the entire year. So month 1 costs him $29. Then month 2, 3, and 4 are still a total spent of only $29.99. Okay? So while hers is going up with each visit or month, his total amount is staying the same for what he paid to begin with. It says describe the rate of change for each function. Well, first of all, Carlos's is the simplest. You'd say Carlos has a CROC, or rate of change, equal to 0. His doesn't change. He pays $29.99, and that gets him for the whole year. Okay. Then for Stephanie, her rate of change, well, how much? Stephanie has a CROC, constant rate of change, of how much? Well, hers is going up, basically $5 per visit, so her rate of change is $5, okay? So that's looking at those. It says who pays more after 2 visits? You look at the table. Clearly, Carlos pays a lot more after 2 visits. Stephanie pays $10 up here. Carlos already paid $29, so Carlos, because, you know, $29.99 is more than the $10 she pays. Who pays more after 6 visits? Well, our table here doesn't go for visits for Carlos. It has months, but we know at 6 visits, he's paying the same. It's $29.99. Stephanie, we don't have 6 visits here, but we can add on to the graph here, so I'd go ahead and do that underneath. And you know it's increasing by $5. So at 6 visits, Stephanie actually pays $30 here. So you'd say Stephanie, because she is at $30. Okay. Notice these are kind of word problems, so I'm answering in words. I'm clearly showing, you know, who's less, who's more. I'm using the person's name. That's the type of stuff you're going to need to do in this assignment, is be very, very clear with your answers, because it's going to be asking you these type of questions. Go ahead and turn the page. And here it has a problem. It says a zebra's main predator is a lion. Lions can run 53 feet per second over short distances. The graph at the right shows the speed of a zebra. Compare their speeds. So we know that a lion, and I would write this in, a lion is going to be 53 feet per 1 second. So write that in there. And now this graph is showing a zebra, so we need to compare. We need to find a rate of change. Okay? So for a zebra, and I would write this in underneath, it says compare using 2 points. So this is kind of where you do the y2 minus y1 over x2 minus x1, where we have a point here, the second point here for the zebra. The y is 118, so it traveled 118 feet in 2 seconds. Then the y1 is 59, because in 1 second it traveled 59. So subtract here, the 2 minus 1, x2, x1, x2, x1, and we subtract, and we discover that our zebra travels 59 feet in 1 second. So when it's asking which one's faster, we can clearly see that the zebra is faster, but only by a little bit. which is why probably the slower ones get eaten. So, let's look at part A here. This is where we need to do it on our own. It says, a certain car has a gas mileage of 22 miles per hour. So the first car, gas mileage of 22 miles per gallon, not per hour. The gas mileage of a certain sport utility is represented by the function shown on the right. Compare their gas mileages. So we know that car 1 gets 22 miles for every 1 gallon of gas. Now what about this one? This is increasing by how much? From 1 gallon to 2 gallon. Well, 1 gallon gets us 19. The second gallon gets us all the way to 38 miles. So we know that this is increasing by 19 miles per gallon. But we need to show our work. So we have to use our formula of y2 minus y1 over x2 minus x1. So this is our first point, this is our second point, that's the y, that's the x. So we have a 38 for y2 minus 19. Then we have our x2 of 2 minus our x1 of 1, and then we get 19 over 1. So we get 19 miles in this sport utility, which is an SUV, for every 1 gallon. So which one gets more? You would just need to say the first car gets 22 miles per gallon, and the second car only gets 19 miles per gallon. It's a word problem, so we need to answer in a sentence in words that clearly shows the comparison between the two. Okay? That's a good answer right there. Sentence, you gave me both the numbers and clearly showed which one got better mileage. Now look at the next page. Here we have 2 trains. I've already read this, so I'm just going to summarize it real fast. Okay? We have 2 trains. The first one is a Japanese high-speed train, the first one they made, and it travels at basically 140 miles per hour. Okay, so m miles equals 140 h. All right. Then we have a second train over here. This is a Chinese train, and here are its hours. It travels 217 miles in 1 hour. So it's simply asking, hey, which one gets better mileage? And you can tell right here, right away, that if you use your formula, just plug in a 1 for h, you know the Japanese train only gets 140 miles in an hour, while the Chinese train from the table gets its mileage at 217. So you just need to make a sentence stating that. Now at the bottom of the page, you actually have to do some work here. It's asking what's the distance for each one after 5 hours? How far will each one travel? Well, for our first one, it already gave us the formula of m miles equals, that's m has one too many lumps there, 140 times h. So we just plug in our 5 for the h hours, multiply that, and you have m equals 140 times 5. That one went 700 miles in 5 hours. Now if we look at our table here, it shows the Chinese train after 5 hours is 1,085. So we just need to write a sentence that says the Japanese train travels 700 miles in 5 hours, and the Chinese train goes 1,085 miles. Okay? Nice, neat sentence giving both numbers and showing a comparison. That's what we're looking for. Make sure you have that written out to the side. There's not too much work with this section, but there is a little bit of writing with your answers, so your answers are clear. Alrighty, next page. Basically, it says the number of new movies a store receives can be represented by the function m for movies, is 7W plus 2, where N represents the number of movies, W represents the number of weeks. The number of games the same store receives is shown in the table. Okay, so I said compare the function y-intercepts and rate of change. How many new movies and games will the store have in 6 weeks? So this one here, number of new games, at week 1 is 3, week 2 is 6, week 3 is 9. So what we can tell here is basically we have an increase of +3 week to week in games. All right. So what would our formula be there for games? Or what would the equation be for games? We would have G games equals 3W for 3 for each week. So to figure out the number of games each week, you have 3 times 6. So the number of games there would be 18 G games for this place after 6 weeks. Then for the other one, we want to use that formula there. So we have movies equals 7W, where we're using 6 weeks for W plus 2. So that one will have 44 movies after 6 weeks. So rate of change for this one is +3. Rate of change for this one here is 7 per week for each week. All right, let's look at number 3. Number 3 says, Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by the function y equals 0.15x plus 49, where x represents the number of minutes and y represents the cost. So basically here it's saying it's $49 just to have the phone. That's your B. That doesn't change. No matter how many minutes you use, it's $49 to have the phone. And then it's 15 cents a minute for every minute that you actually talk on the phone. Okay. Then it says Benjamin's monthly cost is shown in the graph to the right. So if we look at Benjamin here, if he talks for 0 minutes, it's still charging him $60. So here you need to recognize this B for Benjamin, just to have the phone, is $60. Okay. Then we need to look at, okay, at each minute, what exactly is this costing him? Okay. That's his rate of change. So if you look down here, we look at the first point. There's our 60 and 0. That's our x1 or x1 and y1. Then we go over to 80 minutes, and we see that this is our, or sorry, at 200 minutes right here. That is our x2. And then our y2, we know there it's going to cost $80. So what we get here is that it's 10 cents per minute. So circle that 10 cents per minute. And now we can answer the question. It says compare the y-intercept and rate of change. So the y-intercept of hers is 49. So out to the side, you need to say Angela's y-int for y-intercept is $49, and Benjamin's is $60. What about rate of change? You just say the rate of change for Angela is 15 cents, so $0.15, and Ben's is 10 cents, so $0.10. So what we see here is Benjamin starts more but costs less per minute. Angela starts less but costs more per minute. Okay. Now look over here. We need to apply that same idea over here to this one that's not done for us. It says Mandy and Sarah each have a membership to the gym. Mandy's membership is represented by the function y equals 3x plus 29, where x represents the hours with the trainer and y represents the cost. So it's $29 just to go to the gym. That's the base rate that doesn't change. Then it's $3 an hour basically for the personal trainer. The cost of Sarah's membership is shown in the graph. Compare the y-intercepts. So for part D here, it says compare the y-intercepts. you would say Mandy's is $29 because that's her startup, and Sarah's is, if we look at the graph, it starts here right at 40. So we know Sarah's is much more expensive just to join. Okay. Now we look at the hours with the trainer. We have 2 points here. We need to show our work for part E here. So we do our work. We use y2 minus y1 over x2 minus x1. First point, second point. So our y is, we have a 51 minus our y1, which is 39. And then we have our x2, 4, minus our x1 of 0, which gets us, if we do 51 minus 39, we get 12 over 4 minus 0 is 4. So that simplifies. 12 divided by 4 is 3, or 3 over 1. So what do we see about the rate of change? The rate of change is actually going to be the same for both people. It's $3 per hour for each. E then asks, what will the total cost for Mandy and Sarah if they each have 4 hours of training? So this one's the 40 for Sarah, plus 4 hours of training. You take the $3 times 4, you get 12. It'll cost her 52 for Sarah. Mandy's 29, plus for 3 hours, it's still $3 per hour, and then for 4 hours will be $12. So that will equal 41 for Mandy. Alrighty? So that's how we do rate of change. Like I said, most of this section just involves you reading a graph very carefully, looking at the graph, and understanding what's going on. Okay? Last one right here. It says, Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in the table and graph. Which company should she use to rent the truck for 40 miles? Okay. So here we have mileage on the bottom. So we know 40 miles right here, it's going to cost right up there. All right. So we know it's going to cost right about $50 for the graph for 40 miles. Here we're looking at, okay, 10 miles, 20 miles, 30 miles, and then the cost. So it says, find the cost of renting a truck from Ron's rental by extending the table after 40 miles. The cost will be $75 plus another $25 because we know it's going up for 25. So we have 40 miles right there. It'll be another 25 and it'll be 100. So extending the table is a good strategy to use as well. And you can clearly see that this one, Ron's, is way more expensive than that one there. Alrighty, that's it for today. Come tomorrow with any questions.